Hi, my name is Everett Diamond. I'm here to talk to you about the KTM 530 engine case. Left hand side, as you can see here, I have the crank and the piston geometries as well as the transmission geometries. I'm going to show some of the other key geometries, one being the collar bolt holes, which are all defined off the previously mentioned. These collar bolt holes and the other dimensions drive the engine case, which is another fully constrained sketch I want to show you because the outer part defines the main billet. I'll open the part body tree quick. I've organized it in various ways from the inside to the outside, also based on the type of machining operations that would need to be completed, and I've also labeled them to understand what kind of things are going on and association between the different operations of what's happening as well. Now the screen will shift into two as I will show the inside and the outside of what is happening. As you can see, there is not only a large magnitude of operations being completed, but also quite a variability between the different operations that are being completed. Even if it's a stiff or a pattern extrude, it's always done on a slightly different thing, whether it be a hole or a different drawing or sketch and such as that. Also, a lot of the features were developed, and then finally at the very end the holes were cut for the different bolts that are required. And then on the very last operations that were completed were the filleting and stuff for stresses that are noticed throughout the plate. Now to show a goal parameter, by adjusting the stroke length, the height of the engine case increases. Lastly, I'll leave you with some renderings.
Okay, hi, I'm Chris Walton. I'm here quickly to speak to you about the CAD project, which was modelling a 530 KTM engine. Here I'm just quickly showing you the actual kinematics of the model. Started off with almost like a wireframe situation to then work from and start building the component. Okay, so now quickly looking at the part to begin with, we can see first of all we start off with a few pads, and then also we have quite a few different pockets, pads, fillets, and even a multi-section solid in the tree itself. So jumping forward now to where we've done most of the work on the engine side of the part. You can see here most of it's fully defined, it's just missing the actual bearing holes, and then we can start on the clutch side. But first we'll get the water jacket done with the actual multi-section solid before then carrying on to do the rest of the clutch side of the component. Here then we can now see all of it's fully modelled and looking spectacular. Okay, now to quickly show you a little bit of parameterization. Here we're taking an actual spur gear, which is run by the KTM inside the gearbox, first gear to be exact. Here we're running a 10 DP with 19 teeth, so they're quite nice chunky teeth, and also it's quite a nice gear and easily can be seen. So now if we import some new parameters, we're going to change it to a 15 DP with 30 teeth, and you can quickly see how the shape changes. The part can then quickly be changed back. So thank you for listening and watching the video so far. Here's a final rendering of the engine casing.
I can see clearly now, the rain is gone. I can see all obstacles in my way.
My name is Jamie Fox, and today I will be taking you through an overview of the CAD models for the 2010 KTM clutch cover and piston. To begin with, we have here the clutch cover and the geometry set sketches, which include all the bolt holes and main feature locations, the location and size of which is referenced in the part sketches in the model. Also, the outer and inner face planes are created in this set as well, and as you can see, all the sketches are fully defined. The model itself can now be seen, and the main wall sketch fully defined and referencing all of the bolt holes from the geometric sets. All of the features have also been renamed for clarity in the order and meaning of each feature. This model contains pads, pockets, variable and constant drafts, chamfers, stiffeners, constant and face-to-face fillets. The order was done in such a way as to get the main shape and profile first and the surface, and then to work from the surface upwards to produce the outside face, all of these features. And then once that was done, the inside face features and surfaces were all worked on. Once this was done on the inside, all of the fillets over the entire part were made. This is to make sure none of the features break.
Whoa, Black Betty, bam, lamb. Whoa, Black Betty, bam, lamb. Black Betty had a child, bam, lamb. The damn thing gone wild.
Now now we have the piston model. The geometry sketches in this model drive the bore, piston pin, diameter, position and depth of the piston, the length of the skirt. As you can see, all of these have been parameterized and linked to the spreadsheet. Similarly to the clutch cover, all of the features in this part have been renamed for clarity, and the piston also uses the shaft, groove and mirror features. The piston was made starting with the main profile revolved, and the same as the clutch cover, the top face features were added, then the bottom, inside and the piston, and then finally the clean-up and fillet of the model to finish.
Moving to the country, I'm gonna eat a lot of peaches. I'm moving to the country, I'm gonna eat me a lot of...
Hi there, my name is Ben Spencer and I'll be talking you through the CAD construction of the 2010 KTM cylinder head. To start, it is important to identify the critical features of the component for both the ability to parameterize these features and, more importantly, easily understand the generation of them for future alterations or adjustments. On the left here I have a geometry set for each of the main critical features, such as the valve geometry or the cylinder head mating face. In addition to these, I have a reference geometry set for the other geometry, such as the spark plug axes. So now, rolling back to the start of the model, the first feature modelled is the cylinder head gasket face. This sketch uses the parameterized cylinder bore and bolt hole sketches in the cylinder head mating geometry set to then drive the rest of the sketch, as you can see from the yellow sketch lines. You'll notice that the cylinder bore sketch is concentric with the intercept point of the entire model, aka 000. This is because all the major features of the cylinder head are focused around the bore. Now rolling forward, you can see why this is beneficial, with all the features using the centre of the bore as the datum. We have the padded camshaft supports, revolved valves, lofted ports, and finally the cylinder walls and rocker hole bolts. Now for a quick example of the parameterization in action. Here in our master spreadsheet we can change things like the intake valve diameter, which is linked to both the cylinder head and intake valve. These links ensure that the valve seat is correct between the two components, as a full seal is critical for engine performance. Here you can see the effect of the changes. Finally, we have some CAD renders for you to view. Thank you for your attention.
Bicycle, bicycle. I want to ride my bicycle, bicycle, bicycle. I want to ride my bicycle. I want to ride my bike. I want to ride my bicycle.
Hey, it's Everett again, and now we'll move on to the full assembly. So you can see here we have the full static assembly with all the parts mated together. You can see all the kinematic parts as well as all the shell parts and everything else we added. In the see-through you can see the internals. And then we modeled everything in a metallic structure to kind of show the variance that's there. I'll pass it off to Jamie now and he'll show the blow parts.
Thanks, Everett. So here we can see all of the components that go into making up our assembly, all of the static case components and all of the kinematic components, all in exploded format. As you can see from the colours here, we've colour coded all of the faces that are made between the two components. You'll see it again later on with the valve assembly, and this is just for clarity and to see the parts that mate together, the sketches, and to match up. So here we've got the top, the head of the engine, all the valve components, again colour coded, I just saw, and this is to separate intake and exhaust sides. And now we're passing it on to Ben to talk about the kinematic assembly.
For this kinematic assembly, the driver is the crankshaft using the angular command. Focusing on the engine side, the crankshaft drives the cron rod big end through a revolute, and same again to the small end attached to the piston. The piston is on a planar joint to restrict the degrees of freedom to a single linear motion, replicating the cylinder bore. Now looking at the valve assembly, the camshaft is the primary driver for this sub-assembly and is driven off the crankshaft through a gear ratio using 2 revolutes. The rockers are fixed in place using revolute and actuate the valves through a combination of a curvature roller joint between the rollers and the cam lobes and a surface contact between the rocker arms and valves.
Okay, now looking at the gear assembly, the system is using a multitude of point joints and revolutes. The revolutes are there to enable us to get the correct ratios, whilst the pointer joints are there to allow us to get the input and output shaft to work respectively for the given operations. Thank you for watching the video. I hope you've enjoyed it, and I will leave you with a kinematic assembly of our engine in action.